China, with a land area of 9.5 million square kilometers, is the second most populous country in the world, with about 1.4 billion inhabitants, surpassed only by India. Located in East Asia, the nation has deserts, lakes, rivers, and mountains. With China's transformation into a mixed economy initiated in 1978 by Deng Xiaoping, it has achieved the status of the nation with the highest economic growth in the world over the past 25 years. The Chinese economy is currently the second largest on the planet. Transportation in the People's Republic of China is also quite advanced, with the largest railway network in the world, as well as modern subway systems and air transportation. However, what has caught the attention even of specialists are the Chinese water bridges. Imposing, they have been completed with extreme agility and precision. So the question we have in this video is, how does China build water bridges in record time? This is Construction Time. I'm Luciano Guimarães, and in this video, you'll learn about China's perfect technology for building water bridges. China is the global pioneer when it comes to bridge construction. Most of the world's most complex bridges are built by the Chinese powerhouse, and many of them in record time. That's why the world has a lot to learn from it about techniques, equipment, and other secrets of these constructions. But before we dive specifically into China, I invite you to understand how aquatic bridge structures work. Around the world, well, while building a bridge over a valley or gorge can be relatively simple, when you need to cross water, there's an additional level of complexity. Because in that case, the base of the bridge will be submerged. Ensuring stability in this scenario requires properly securing the foundation to the bed of the ocean, lake, or river in order to prevent the bridge from being carried away by the current. 4 main methods of underwater construction have been developed around the world and improved to make robust underwater bases possible, adapted to each condition and the type of bridge in question. The first of these is called caissons, large hollow structures lowered into the water, down to the ocean floor or riverbed. Water flows around these structures, allowing workers to dig through the loose sand to reach the base. Used for bread, which will be used for construction, a bread that will be used for construction, a construction bread which will be used for a bread used for construction, a bridge which will be zanato. Another technique is the cofferdam, a temporary circular structure built in the water, made of materials such as solid wood, stone, or steel. Similar to a dam, the cofferdam holds back the water, allowing it to flow around the space enclosed by this structure. Afterwards, the water is pumped out of the enclosed area, leaving it completely dry and suitable for work, such as placing concrete or building steel structures. The third approach is driven piles, which are similar to driving a nail into a piece of wood. This involves a machine that drives hollow metal tubes, called piles, into the underwater bedrock from top to bottom. Then, these steel tubes are filled with concrete to solidify them and give them greater strength. One advantage of this technique is that it eliminates the need to divert the water. The last method is called offsite building flooring, the lorry in English. It involves manufacturing the base of the bridge off-site, for example, in a factory. Then, this base is placed on a barge and taken to the appropriate location. Finally, the structure is lowered into the water down to the riverbed. Once positioned, the structure can be anchored to the riverbed using piles. Of course, building bridges with foundations that are submerged requires overcoming several challenges. Let's mention 3 of them. The first is finding suitable materials. Many of the materials often used on land, like wood are not suitable for long-term underwater use. The second is dealing with water pressure. Both during construction and throughout the lifespan of a structure, the effects of water pressure play a fundamental role. And the third is corrosion management. But what has China been doing differently from these aquatic construction methods? And why did it need to resort to these innovations? It turns out that, in the past, the spans of bridges built over the Yangtze River were not very large. Now China is building bridges with larger spans because there was a need to balance the demands of cross-traffic and increase maritime safety, since China's domestic waterway transportation is very busy. However, building bridges with longer spans faces another obstacle. The larger the span, the more difficult the technique and the more expensive the bridge becomes. To cleverly get around this, Chinese engineers innovated and used multiple continuous spans to cover the navigable waters by joining the bridge spans into a single interval and reducing construction costs. For example, the Taizhou Yangtze River Bridge is the world's first suspension bridge with 2 spans and 3 towers, with a span of several kilometers. When Chinese engineers planned the Taizhou Yangtze River Bridge, they used the river tip section at the bridge location and installed a tower in a deep water area, using 2 large spans to cover all the navigable waters of the river. Thus, the need for navigation was met and the span of the bridge was reduced. Compared to the conventional construction type, by using the 3-tower scheme, the span of the bridge can be reduced by half, and consequently, the project cost also decreases. The second innovation of Chinese bridges is the new 3-cable plan structure. It is a structure proposed to adapt to the construction of multifunctional bridges. That is, bridges that carry multiple traffic functions and combine high-speed railways. Intercity railways, expressways. The traffic bridge is a wide structure. The structure is improved within the scope of Arvore, inaugurated in 2009, and has a central span of 504 meters. Later, the same structure began to be widely disseminated, contributing to the advancement of bridge technology around the world. China's third innovation is the rotating construction, which consists of using the land on the coast and 2 mountains on both sides of the bridge to assemble it in a convenient location instead of assembling it in its final position. The Yadixia Bridge in Gansu is a large bridge that uses rotating construction to join the ends together. The 2 rotating support points were first joined on both sides of the river and then turned vertically for the first time to reach the bridge's lifting position, and turned horizontally for the second time to reach the bridge's center line. The fourth innovation is the overall prefabricated assembly. When this technique was first used, the load-bearing capacity of a bridge's beams in China was only 80 tons. Currently, the span of prefabricated beams for China's high-speed rail reaches 40 meters and a weight that exceeds 1,000 tons. The fifth innovation is the bridge across the sea. China has an extensive coastline with 32 meters of inherent challenges in aquatic construction, as already mentioned in this video. In China's case, building a bridge across the sea also means it has to be very long, which increases its complexity. Because of this, the conventional method of building bridges across the sea in rivers and islands was not enough for China's case. The bridge needed to be prefabricated as a single bridge and assembled as a whole bridge. To make the project feasible, China used a small island called Shenzhuan in the sea as a base for the prefabrication of the beam body and a special transport to lift it. But the innovations don't stop there. One of China's biggest investments is in the development of new equipment capable of overcoming practically any limit. That's the case with the SLJ 900, also known how. When it's supported on both pillars, it moves a bridge segment forward, fitting it into the gap. And after this phase is completed, the machine moves again, but in the opposite direction to fetch the new bridge segment, repeating the process. With 90 meters in length, 7 meters in width, and weighing 580 tons, the SLJ 900 reduces bridge construction time by about 60%. Assuming that the average time to build a bridge using conventional methods can be 4 to 5 years. The Golden Gate, for example, was built from 1933 to 1937. With the SLJ 900, that time would drop to about 1.5 to 2 years. Besides the technological advancement mentioned, there's another decisive factor for China to build bridges in such a short time. It's the political landscape. With the Chinese Communist Party in power, the Chinese government adopts a unified and long-term planning approach. When the government leadership decides to carry out large-scale projects, they are executed without the need to wait for approvals from multiple levels of society. On one hand, the Communist Party is the only one in the country, and in this way, the Chinese government holds total control over decisions, with no political freedom for the citizens. But on the other hand, the country is far from the bureaucracy present in several nations, which often results in slow project implementation and high costs. China has stood out in building water bridges in record time. The country takes advantage of technological innovations to carry out and optimize the construction process. In addition, the policy, characterized by unified leadership, allows projects to be carried out without delays. But there are other major challenges underway. In this year of 2023, the zero COVID-19 policy seems to be the broken one, the most important for the country. And the other issues, such as the fate of the economy, depend on the easing of the harsh restrictions imposed on the market by the Chinese Communist Party. And do you think China will be able to maintain this pace of growth for a long time? Share your analysis in the comments. I'll wrap it up here and see you in the next video.